Greetings, everyone. We are so delighted to have you with us participate in our APAC Fusion 360 group meetup. Today, we'll explore some of the new Fusion 360 functionalities and listen to or share some of the use case studies and also learn from each other. We'll also deep dive into the ongoing design and manufacturing trends in the side of design, traditional manufacturing, and additive manufacturing. My name is Varun Neta, and I work as a Fusion 360 community manager at Autodesk. And I welcome you all for today's session. Thank you so much for taking time to be with us today. This is today's agenda. We'll be discussing on product design and how to maximize your capabilities using Fusion 360. Then we'll be seeing some design workflows for additive manufacturing. We have great speakers with us today. We'll be also checking out, what are the manufacturing practices in traditional manufacturing. And then we'll do a quick round of robin for AU 2021 and followed up with Q&A. Back in 2013, that was the time when maker movement started spreading in India. I was also into, woodworking, robotics, Arduinos, and RC planes. I used to design and fly and teach about hobby drones, which involves a lot of 3D printing and rapid prototyping due to the customization. When we create gimbals and all those things, there's a need for creating specific sockets and components. So later in 2015, I started customizing drones, majorly for FPV flying and hobby aerial filming projects. And that was the time when I started using a CAD package to support my work. Later, I shared these designs on open platforms like Thingiverse. And I see these designs were used by a lot of passionate people where they even made modifications, right? So you can see there are like gimbals and prop savers and many other stuff. That is how I started using a CAD package. And I wanted to start with a group activity. Just share your thoughts in the comment box, in the chat box, like what made you start with a CAD tool? You might have some experience working on a project, you're doing something. We would like to hear from you. And we'll also give opportunity to a few of the participants to be allowed to talk, to share your story. I think we can start with Yuji. What made you start working on a CAD platform?
Well, I learned in school, and I was a product designer, right, back then. And obviously, it was already one of the process the company was using to develop their designs. And that was the beginning, and I loved it. Yeah.
Cool. All right, we have some interesting people with us. Hi, James.
Yeah.
Would you like to share your story? Yeah.
Yeah, sure. I came out of First Robotics, doing that for a while, and wanted to jump into the combat robot space. I've always had an interest in it, and wanted to design my first machine. I learnt 1-2-3D design at school, and decided I had a student license for Fusion 360. Just trial and error, learned that, and that's, I've been using that for a while. I'm pretty good at it, and that's where I am now.
Cool, great to hear that. Let's also hear from Richard.
I guess you can hear me.
Yeah, loud and clear.
Yeah. I was working in a steel metal fabrication workshop, and we were developing and delivering relatively simple components, but with multiple complex assemblies. So yeah, I've moved away from sort of basic SketchUp type things, but have found Fusion 360 to be more flexible and better overall in developing these assemblies than I tried Rhino, and way back in the early days was working in Maya. So yeah, Fusion seemed to cover off more production style product design. So yeah, that's where I came from.
Nice, love to hear that. Let's take it over to Lokeshwar.
Yeah, so I have started with regular 3D software, but then moving on to Fusion, the parametric design features. they really attracted me and like enabled me to make my models a bit more customizable, a bit more functionable. So yeah.
Nice. You also mentioned that your projects were related to mostly to electronics.
Yeah. So I usually work with SoCs like Arduino and sometimes Raspberry Pi. So designing stuff that maybe holds those things in place or like holds maybe motors in place. So models like that is what I mainly design.
Nice. Thank you for sharing your feedback.
Yeah, thank you.
All right, going ahead with Mihir.
Yeah, hello. Thank you for providing this opportunity. So I
Bit
started
louder.
with,
Yeah.
okay, sure. So we had an AutoCAD workshop at our college, and our seniors guided us very well. So I was just mesmerized by looking at the bicycle and all that they designed. It was the first time I was being introduced to this software. So from there onwards, I learned SolidWorks and Fusion, and later on CATIA and many other softwares. It was a great experience. And basically, Fusion, why I like Fusion is that it's cloud-based software. So all the data is like precisely stored and you can access it from anywhere. So that was the best part of it.
Interesting. Thank you for sharing your feedback. And let's take it over to Maria.
Hello.
Hi.
Okay, I have been working in MYP design for many years, and this year we started to use Fusion 360. We were using some other CAD systems to model for 3D printing and laser cutting that we have here in my school. So this is new for me. Precisely, I wanted to ask you something. It's because I am in a different time zone, and I thought 11:30 was perfect for me, but here is almost 2:30, and I have class in 10 minutes. So you are going to put the recording so I can take it, yeah?
Absolutely. We'll be recording this and putting this on our YouTube. So we'll share this link with all the registrants.
Okay, thank you. Yeah, so I'm really happy to be here because I just made some tutorials on Fusion 360 and found it really interesting and good. So it's new for me again, and I'm so happy to be here to learn from you and from others. Thank you.
I'm glad to hear from you. Thank you. Hi, John, over to you. Hey, John, I think you are on mute. Maybe you can unmute and share your experience.
I think that's on mute now.
Yeah.
Yeah. We were looking at drones. So our problem was that we were trying to get drones to fly over rice paddies and look for weeds in them and fix weed growth. So the pesticides could be dropped just in the right spot on the area. So it sort of started off as photography and then moved across to artificial intelligence. So on the AI side, it looks for the weed growth and spots weeds in the paddocks and then maps them out. But the problem was that the drones, we started with quadcopters and then have to move across to aircraft. The reason being, quads can't stay in the air very long, whereas an aircraft can stay there for quite a long time. And the problem was we needed something in between them. So lots and lots of design change for a very short period of time. The CAD tool is the only way to do it. You know, there's no other way than 3D printing.
Awesome. Thank you for sharing your feedback, John. All right, guys. Thank you so much. We can see we have such an interesting set of audience today. How do you feel about this, hearing this amazing feedback, Yuji? See different perspectives, different applications.
Yeah, it is amazing, you know, and then all my friends, you know, all my customers, you know, even like colleagues, you know, they all have found a different path to reach where you are right now. But we all equally, you know, appreciate and enjoy Fusion 360, although I work at Autodesk. Besides that, I love Fusion 360 as my personal opinion, and I do create my own stuff. So I'm really happy using or being as a Fusion 360 user. And I'm happy to hear everybody has a similar experience on that. Yeah.
Awesome. So moving forward, so guys, when we talk about great design, So usually it has that wow factor that makes products more desirable and services more appealing to people. And designing right now in this today, designing is more than creating products and services. It can be applied to systems, procedures, protocols, and customer experiences. And literally design is truly transforming the way all the leading companies are creating value. The focus of innovation has shifted from being engineering driven to design driven, from product centric to customer centric, and from marketing focused to user experience focused. And here we have Yuji Fujimura with us. He's the one who leads Fusion business in Japan and Australia. He's like super energetic, super humorous. He's a creative professional. He was also my teammate back in 2019. We worked together for like 3 years as Fusion 360 evangelist. And he's going to take all of us to do a deep dive in the world of design and how to maximize efficiencies using Fusion. Hey, Yuji, over to you.
All right, thank you. Let me share my screen. Quick. Yes. Can you guys see my screen?
Yeah.
Yes. All right. My name is Yuji Fujimura, making this presentation from Japan. And I'm about to get the typhoon outside of my house. So if I ever disappeared, it means what it is. Maybe my house is gone. All right. So today I would like to talk about how you can maximize Fusion 360 through the implementation process. What I mean, it really is that, what are the benefits that the Fusion 360 customers have found, over years, by using it, and everybody find a different point, or key point that, within Fusion 360 when they start using. But some people experimented, expanded, the way they apply, Fusion 360 over to your design and engineering. And then I would like to introduce some of the case studies from Japan, they're unique and very fun. Oops. All right. So the benefits felt within a few months of implementation, within the first several months, he definitely felt the value by using Fusion 360. So this company is called Noguchi Motors, and they have established, believe it or not, 1896. So it's almost 120 years old company, right? And they moved to the car, automotive car business from 1915. So they've been doing this custom car market industry for more than 105 years old. That's really amazing. And there's creating these special purpose vehicles, so-called working vehicles, such as fire trucks, police cars, medical device or medical vehicles, or cash truck, or like a kitchen cars. They create all these customized vehicles, and they started to use Fusion 360 about 3-4 years ago. And then I did interview, and I would like to share more story, from their comments and feedbacks. So this is 2 images that they gave it to us, and hold on, let me just close this right here. So this is the image that they gave us, assembly shots. In engineering, leader Takezawa-san is the guy I made an interview with. And according to him, every job that they create is this custom-made cars, and they work on the body work, frame construction, interior lining, sheet metal painting, sheet covers. All these needs and requests are different by every client. But challenges at the same time, this is a car. Although it looks like the customized car, but it's still going to be on the road. So that means these special cars need to fit the regulations, to be able to officially manipulate on the road. There's a traffic rule, right? And according to what he said, he's been doing or designing or engineering, in 2D CAD, which is AutoCAD, and for a long time. And he probably spent like 8 years designing these special car in 2D CAD days, so 2D base only. And he recognized there are a few challenges, that he was facing in daily engineering. And one of them is when he designed these open hatches or very complex move and joints, it is okay when axis is only one axis, but, when they have more than like 3 axes, 4 axes, to create or to design these open hatches or some moving components, the designing or engineering become really complex. And he was having very trouble or difficulty designing complex moving components and parts. So he felt the limitation of 2D CAD or 2D designing approach. That's why he started using Fusion 360 to begin with. And his first project was this car in the photo right here. And he took 2 months to develop this whole designing in 3D with Fusion 360. And then, believe it or not, this is the first project he made. And in a way, on the other hand, you can say he took only 2 months to develop this car. And he said that Fusion 360 is very easy to use. And as a proof, he told me that there are more than 10 projects that he is currently working. And so I think it's amazing how people or engineers in the Noguchi Motor could adapt the Fusion 360 in a very short amount of time, and they were really happy. So I'm going to move on. And one of the advantages of using Fusion 360 is that it can reduce the interference problem, because there are like difficulty or limitation in designing or engineering, object in 2D dimensionals. They used to found a lot of like parts interference, even during the process of final production development, they found all these interference, and they used to like cut down or grinding or modify parts on the development process. But right now they told me that, they reduced these interference problem 90%. I think, the reducing the mistake or problem 90% down is really going to give big impact. Imagine you're working with 10, 20 people, together in your company, and you're working with a Fusion 360, and think of the impact that every 10 people or 20 people reducing their mistake 90%, right? Or maybe not just a mistake, maybe time wasted, reduced 9%. The impact is so big. And this is quick comparison before and after in quantitative and qualitative. And obviously, I repeated, many times that, there was a limitation in 2D, and with the Fusion 360 using 3D modelings, assemblies, it helped them. Also, he highlighted the center of gravity, center of mass. It was really difficult for them to have accurate location or spot, of where it is. But now with the Fusion 360, with the physical material applied, it's so easy. Just one button, you can check the center of gravity, within whole assembly. He's really, really happy, finding out those, because it was taking so much time to get that. So I would like to introduce another case study right here. And this is called Kita Nihon Juryo. I know it's a little complex and sounds too long. So on the other hand, the other way to put it in English, it means North Japan Heavyweight. That's the company name. So the Kita Nihon Juryo is developing this unique moving device to move, actually, as you can see in the photos, the huge metal chunk, which weighed 100 tons or 200 tons. All right, so moving on. So Fusion 360 greatly improves the safety and efficiency of heavy lifting operation, which are always dangerous. Obviously, you can imagine you don't want to be nearby 100-ton object moving, right next to. And this is very unique, and it really stood out. I'm just leading his comment, his CEO, Hideki. So Hideki said that in the past, the only method of moving heavy object was traditional method of towing them with a roller. It sounds like we're hearing the story how people or Egyptian build a pyramid even, but truth is, even this age, this period, in many areas, many industries, many locations in the global, worldwide, people are still towing these heavy objects with a roller, you know, and that's we have a very great surprise. And he said that he wanted to change the world and then make it more safe, you know. I completely agree. And there's a video that he created, you know, in Fusion 360, and that is 3D animations. And then I'm going to play just 1 minute for that. Hopefully that's, you can hear the sound. Do you hear sound? Well, yeah.
Yeah.
So all these animations were created within Fusion 360 with assembly data. Oops, sorry about that. I guess you can see it is super clear. 200-ton object, right? And it almost like 200-ton object got legs to it, and then it's almost like walking on the street. And then you will see the actual the site, you know, I don't know how big this is and how much the weight this is, but it's almost like making me saying it's cute that this thing is having the legs and moving forward. And what's amazing is that this device allows this heavy object to move any direction that, you know, you want, right? And maybe in 10-20 seconds later, you will see this object like rotating, not just rotating, it moving diagonally, you know? So now it's moving forward, sideways, sidestep, and then from here, 45 degrees, it start moving diagonal, you know? It's amazing, like this one, right? It's super cool. So they developed this device for the these special or unique site and field and locations, and they said they gain much more trust from their clients and customers. And in fact, after they start using Fusion 360 with these 3D animations, this customer start gaining or winning more project from their existing customers, because it's super clear that is how this operation will be planned in advance. And also they use a simulation function attached or bundled in Fusion 360 to be safe, you know, and to make sure the safety factor is good enough and kept enough. And this is also amazing. And I like the term that they chose, a life-saving 3D project with the Fusion 360, you know. With the Fusion 360, they're trying to save lives, you know, by making sure every environment is super safe. And then, you know, you see the four guys, gentlemen right here, and some of them are sales rep, not the engineer. But the CEO made a training to every employees. I think there are like 15 or 20 employees. They train every single one of them with the Fusion 360 for them to be able to make a presentation or modification at customer site, how or why they're planning, you know, these movings or like operations in certain manners. And I'm really happy hearing not just only engineers using, salespeople learning Fusion and using it and utilizing and getting best benefit out of it. And then he's moving on to the next level, and he said he planned to expand his 3D capabilities as a company, and he would like to spend, like, you know, some investment for the VR or scanning data, you know, for them to have more clear, accurate map of the site, you know, just like you see here. So as a conclusion, you know, not just that, you know, they're happy of, you know, converting themselves from 2D CAD designing or engineering to 3D CAD, you know, engineering. They found the value in 3D animation, and they used it, you know, a lot. And they even made a customer happy to earn more project, you know. Yeah, I believe this is a great story. And then there are a few more. I mean, there are hundreds more case studies, but I would like to pick a few more. This is a company called Mizuno. You might have seen some of their sports gear, like a tennis racket or shoes, for example. And there's a designer named Nakamura, Mr. Nakamura, right? and he designed this crazy looking, bouncy ball looking shoes. And because he is working in advanced design team, a lot of production design team, and I like the way he put together and then express himself, when a shoe designer use 3D CADs and like 3D CAD, they expand their capability, and then they expand the capability in the communication with, especially with mold engineering, mold engineer. And then as you can see, this bubbly, bouncy ball looking shoes, it's very difficult to actually explain the concept and the visual and vision to the mold engineer, because it's so random and it's so hard to make 2D technical drawing out of it. It's almost impossible. And so that he decided to take advantage of using 3D CAD and by himself, and he created model in Fusion, and he gave it to the mold engineer. And the shoe came out just as it is. He planned it in his head, and he really loved it. And then after Mizuno released these shoes on the market, and the best feedback he thought was people saying, this is sick. It's sick is all right, sick is sick, but people use it as a slang, as a compliment. And by the way, and I'm not sure whether you can see it, but I have the shoes right here in my hand. It's very unique looking and very different from usual shoes like sports shoes. And with the current technology, with a 3D CAD like Fusion 360, they can achieve something like this, within short amount of time. And then there's another shoe that they developed. This is the 3D printed sole shoes. I also have it in somewhere there. Yeah, right there. It's also very unique. This wasn't possible maybe 20 years ago, but now with additive manufacturing technology, it became possible. But to use even 3D printing technology, you need a 3D data. And so the product called like Fusion 360 or Net5, and maybe sometimes Dynamo Studio, Autodesk has some of these like generative design technologies. I think it might worth, trying these new technologies for your project. And there's another one called Akerun. It's just a smart lock project, from a startup company. And then your traditional door will become like automated, like a easy smart lock with your smartphones. I think they're growing their business. When I talked with them, there were only 10 people startup, but now they have like 50 people. So they've been growing so fast. And there's another project, as Varun was initially showing you, the little drone project. And in Japan, we also have a great talent, using developing developing drone with a lattice structure with the Fusion 360 and the Net5. So this one, I have the video that's as a proof that it actually flies. And then, the developer or project owner or like a designer or engineers, for this project, they were like 18 years old and 19 years old students who's developed this drone with only 3 weeks. And it is amazing, what can Fusion 360 offer to these great talents. It doesn't matter how old they are, as long as you challenge yourself, you can create all these great projects and products. And for you to have best outcome with the Fusion 360, you can do several things. I strongly recommend you to try other functions. Just like the Kita Nihon heavyweight, they discovered the value of 3D animations. And maybe you might have find like another value within other features on Fusion 360. So I strongly recommend for you to test every functions. Rendering, have you played with it? Generative design, have you tried it with it? Just don't be afraid. There are more contents, tutorials available online. So just keep on trying new things, and it will probably open your eyes more and expand your capabilities. I think it's great stuff. So recommendation 2, I know that you might enjoy playing, Fusion 360 at house alone, but I strongly recommend you to, run Fusion 360 with other department, other colleagues, partners, or customers, clients, find somebody who could use Fusion 360 together. And it's always best to try these new technology, with somebody else, and in, a lot of self-taught, maybe you exchange more informations. And I think it's very important. And recommendation 3 would be, there will be so many like learning contents, and every month we're releasing the new updates. And sometimes I see the people stop learning, that's a little sad. Every month we're releasing new package. So just going to check what's new Fusion 360, quick Google search, and then you'll discover new function. Maybe today it's not available, but next month it's available. So who knows, just check out these features, I recommend. And this is my last slide. Join the community. And well, to be honest, like today is a meetup, and there are currently more than 100 people joining, and thank you for coming. But there are more events like Autodesk University is happening within 2 weeks. So just look for the information. That's what I'm saying, on social medias, online webinars. There are more information available from Autodesk or non-Autodesk contents. And just like, again, expand your knowledge, and additions, and that would help you develop better products in probably like short period or long term, who knows. But I think it's very important for you to have antenna up, and then gain more information. All right, so thank you for listening, and this is my last slide. And please do make registration. Autodesk University 2021, right? 22 is next year. So sorry about that. I'm living in future. So back to you, Aaron.
Thank you, Yuji. So guys, truly, you see such innovations, the level of work people are doing. Totally, I can say, sky is the limit for this. And now I invite the other great person with us, Peter. Peter is a technical sales specialist, and he's from Autodesk Japan. And he will take us through some amazing insights on the additive manufacturing world with Fusion 360. Over to you, Peter.
Yeah, thanks, everyone. It's great to be here. And usually I'm more involved with the NetFab products, which is very specialized for 3D printing. But if you've been keeping up to date with some of the updates that Yuji was talking about, you'll see that there is a ton of additive manufacturing capabilities coming into the Fusion product. So just like our logo, the Fusion product is getting updated very quickly. So make sure to have all of the updates done so that we can bring you the best technology. So today I wanted to go over some of the things that is really exciting for me with the Fusion product in the additive world. A lot of stuff that we've never really had a great amount of access to before. So a little bit of background on me. So my background is mostly focused on 3D printing rather than the CAD design side. So it's quite a lot of the time where I'll be kind of piggybacking off the awesome design work of guys like Varun that have thrown their designs up onto Thingiverse, and I'll download those Thingiverse designs, and I'll start to play with them, and we'll start to adjust some of the mesh, and then take it for 3D printing. But what I wanted to introduce today is actually to go through some of the software new capabilities, click through in the software so that you guys can see what's going on, and talk about some of the new technology. So I'm going to quickly switch over my screen so that you should be able to see where I'm at. You should be able to see it coming through now. I should have Fusion 360 open. If there is any issues, somebody stop me and let me know. But effectively what we've got in here is, if you have a look over here, we've got a mesh body that I've just brought in. So within the Fusion design workspace, there is a mesh tab. So if you have a look and open that up, you can go insert mesh. And what I've done is I've just brought in an STL that I've downloaded. There's not really much that I can do with it as a mesh. And in this case, what I would love to do is to kind of add a bit of fillet onto each of these edges so that I can get a bit more of a rounded design. If you've played with meshes before, you'd know how difficult it is to try and get triangles to be curvy. So what we're going to look at doing is actually converting this back into a solid and then taking it through to the 3D printing workflows. So with these kind of meshes, it can be very challenging to do anything with them. What we're going to do very quickly within Fusion is I could go in and I could T-spline and create like all of these different sections of the design again. But that would be kind of a waste of time with the new technology that came out. I believe it was 2 releases ago. So within the mesh section, what we can do is we can jump into prepare. And what we can do is there's a section here called generate face groups. So if I click on that, select the geometry, I'm going to use the accurate settings here because I know that with some of these curves, it's a lot more accurate at capturing the gradients as well as understanding where the different sections of the curve are breaking and where the next curve starts. And what I'll do is I can just turn on this preview checkbox here. What this is going to do is it's going to have a look and analyze the geometry. It's going to tell me where all of the different surfaces are. And as you can see here, if we look at it from the top, we can kind of see that there is a curve here, which kind of splits into the next curve, a different R on this section here. So all of the R's are relatively well preserved. You can see that it's connected all the sections that needed to be connected. And if we were going to be looking at a solid version of this design, we'd be able to notice that it would be looking very similar to what we'd be seeing here. So this was, again, about 2 seconds or 3 seconds of calculation. It's popped up with this in what I must say is incredibly cool colors. I'm a big fan of the pastel workflows here that we've got. It definitely makes me enjoy the work a lot more. And if I go OK, what I can do here is it's actually going to select these, create faces from this. And now the software is pretty much ready to convert this to a solid. So if I jump into the modify section here and go convert mesh, I click on this and select prismatic. Let me just quickly show you what happens if I go with faceted. So I'm going to select the geometry. I've got faceted selected. What it's going to do is it's going to turn each of these triangles of that design into a surface. So this is a solid representation of what I was originally looking at. But if I wanted to do any adjustments to this, it still is a bit of a pain. So I'm just going to quickly Control Z, flip it back, and would go into prismatic. Select the geometry again. And once we've done that, as you can see, this is now a 100% solid. It's a fully CAD accessible design. I didn't have to go through, re-sketch it, extrude all of the different sections. It was incredibly quick for me to just select and go from there. Once I've done that, I can go into the solid workspace. As you can see here, it's switched from a mesh to a solid. So if I wanted to do anything such as what I was talking about before, going in and, for example, adding a fillet to this surface, I might want to add maybe like a 5mm fillet. That's looking pretty good. I'm happy with that. And then I might look at, adding another fillet here. So again, I can do this with absolute ease. It's fully parametric. I can do any adjustments. I can make anything that I would as per a standard CAD file. And I can then, for example, take it back into the mesh and I can retessellate this if I need to. So I can click on the geometry. I can have a look at the preview. It's going to create it based on these inputs. So you can see that it's actually not only adjusted the design and created reflected the sections that I've adjusted here, but I can actually take a very rough looking mesh and I can, for example, turn it into a high quality mesh. So as you can see here, the number of triangles has increased and it's a much more accurate representation of the geometry, especially in some of these more curved sections that we've added. For the time being, I don't particularly want to turn it into my least favorite file format, the STL. What I'm actually going to do is I'm going to throw it into my Ultimaker machine. So I'm going to go into from the design space to the manufacturing workspace. Within here, we can see there is an additive tab. And I'm just going to straight away start setting this up for 3D printing. So I can jump into new setup. I can select my geometry. I can jump into the different machines that we have. Within the Fusion library, we have a ton of 3D printers already listed. So if we're going to be using one of the more commonly used FDM or FFF technologies, we can have a look and see all the different machines that we have here. I personally have been recently using the Ultimaker S5, so I'm just going to jump into that machine. we have the representation of the build space, of course, showing here. The part I already have selected. I can also jump in and check out the print settings. So, if I want to be doing it at a layer height of 0.2 mil, or if I wanted to be doing it a bit thicker, I could actually say, well, I've made the effort of creating these curved surfaces, filleting it. So I want to actually represent that a lot more nicely without having those relatively ugly looking steps on some of those edges, which you'd probably see with the FFF or FDM methods. So I'm just going to select a 0.1 mil layer height. It's going to add a little bit more to the build time, but I'm more interested in catching the quality. So what I can do there is I can just go, okay. And once that's happened, it's already brought the part in, it's already added the settings, but this orientation probably isn't exactly what I would want to be doing for 3D printing. So what I'll do is I'll just jump in, automatic orientation. I can select the part that we're looking at. The critical angle here is talking about where we would have support material. So the support material helps to ensure that we hold it in place, also make sure that there is area for it to build so that we don't have air prints. It also helps us to make sure that the part reduces deformation, these sort of things. So what I'm going to be doing is I'm just going to be using the default settings here. It's going to do a quick calculation to see what the different orientations available are. And then once that's done, I can jump in and go check the results. So the optimal one that it's saying based on my inputs and my parameters and my ranking is, again, looking at having the amount of support volume, the support area, bounding box, and part height all relatively averaged out. And that's what we'll be looking at with this design here. There are, of course, other ways that we can go. So that's the initial. There is this design, this orientation, and each of these have all of the information that we'd need to be looking at. To reduce the amount of support material as well as reduce the build time, I'm just going to keep it relatively nice and flat like this. I have been playing with metal printers where we would generally have a bit of a gap in between here. So what I'm going to do is I'm just going to bring this down and place the part on platform. What this does is it just means that the gap between the part and the platform is going to be removed so that it's nice and tight on there. Next things I would look at doing is if I wanted to change any of the settings for the 3D printer, I can jump in and change all of the information for the, the different extruders. I can change it based on the different materials. I can, of course, save these as well so that if I wanted to be constantly using the same settings, I can do that as well. But I'm just going to be using the base settings that I have for this machine. So again, based on that, that's just looking at this settings. And if we wanted to create more settings, we could jump in and create a My Settings where I could fully adjust all of the details. But for the time being, I'm just going to use the defaults. Next, if you've used 3D printing before, you might know that for these FFF machines, there are these infills. If you have a look at when I hover my mouse over infill, it shows us what we're looking at. It's kind of creating an internal structure to help us reduce the amount of material consumed in the build process. Based on the geometry that we're looking at, I might look at going from, instead of a gyro, to a honeycomb style infill. I can look and adjust all of the infill information if I want, but I'm pretty happy with what it's looking like, so I'm just going to run with it. I can also adjust all of the ways that the supports are going to be generated. Again, these are all the settings that I've previously been using, so I don't really want to mess with them, so I'm just going to leave them as they are. And then we would just go in and do generate. So once we've clicked generate, it's going to be creating the toolpath based on this geometry, the settings that I've put in for the infill and the supports. If you're familiar with latticing and these sort of things, like what we're looking at with the shoes, it's going to be taking the design and creating within the geometry an infill style geometry. The difference with these is that the infill is created on the slice level. So it doesn't actually live within the geometry. But when you look at the way that the toolpath is generated, the G code will have created that nice infill to help us reduce the material. It also helps us to reduce the build time, and it just helps to keep the overall costs down. So once it's kind of, there are, of course, other tools that come with the machines that if we did want to be using them, we could do that as well. But one of the things that's really good about this is if we did, for example, want to make a late stage design change or something like that, we can of course jump into the design side, and we can very quickly adjust that, add a hole. We could remove that hole if we were going to be adding it in later, and then we could jump into here, and it would be updating this geometry so that we have all of that parametrically linked. And we can just click refresh on the toolpath if we did want to be doing that. So we can see that the toolpath is almost ready. The geometry again was relatively large, so we are taking a little bit of time on that, and the settings that I did put in have been quite complex. So it's just applying that as well as adding the infill and creating the supports. So this is generally what you'd be doing in, for example, some of the, in this case, the Ultimaker technology. They do have, of course, software that you can use for this, but it does really help with that iterative process, having it all in the one tool. Ultimaker does have digital factory technology, so we do have great links with the Ultimaker technology. So from within Fusion directly, we can connect to your Ultimaker account, and this will really help you to directly send those designs and all that prep work that you've done onto their cloud service so that you can send it directly to the machine, manage it, save all of that information as well. So it can be a really great tool to help you optimize your Ultimaker usage. If you're interested in that, you can download the add-in for this. If you jump onto Google and just type Fusion360 and Ultimaker, this will probably be the first thing that pops up. And then you just go add integration. And once you've done that, if you open up the Ultimaker machine, you'll be able to see this as well. So we'll see that the toolpath is almost finished being created. With the toolpath creation within Fusion, we also have a full range of post-processor libraries. In this case, you can actually see that we've got the post-processors for the Ultimaker technology. So once we are happy with the toolpath that we have just created, we can post-process this and send it so that it's in a readable format for the Ultimaker technology. Now that the toolpath has been generated, we can go simulate additive toolpath, and we can actually see what's going to be happening with the toolpath that's being created. So with the 3D printing technology, again, it's a layer by layer process. So you can see that there are different things that are happening within this design. You can see the different color coordination of what each of these toolpaths are doing. So it's creating like a skirt to kind of help it, adheres to the build plate. You've got the blue sections that are going to be the supports, and the orange sections being the geometry. As we move away, we can actually see that there is the honeycomb that we selected as the infill being created here. Again, we made it relatively small, so it is helping to reduce the material, but we do have the ability to further reduce that. This part itself is relatively high stress part, so we want to make sure that we have as much volume in here to keep it as strong as possible. And as we continue through the build process, you can see the full simulation of where the nozzle is going to be moving, and that's really going to help you to understand whether or not there are any issues with this, and if there's going to be any collisions. Usually it's looking pretty good, and you can see each of the nozzle movements in this simulation as well. So it's quite a useful way of doing it. So I definitely suggest, if you haven't used any of the additive technology, again, the mesh workspace is, from my perspective, as somebody that's been spending way too much time trying to clean up meshes and fix meshes and these sort of things, if any moment that I can get away from an STL file is heaven for me. So using this mesh space to actually take a mesh and make it solid, as well as then taking it into the manufacturing workspace and having direct integration with, for example, your machine maker as well. It really helps to make this a smooth workflow. Quickly, I would like to show a use case, one of my favorite topics, beer. I'll show, let me just quickly reshare my screen so that I've got the sound. Yep, okay, that's looking fine. So I'll share it now, and you can watch one of our customer.
Within Heineken, we are located in over 70 countries. We have over 150 breweries and produce more than 250 brands globally. Sevilla is one of the breweries that we have. That's one of the breweries where also multiple brands are produced. very interested in looking how digital innovations or new technologies can help us to increase our end-to-end productivity, and therefore we're looking into 3D printing to validate and identify how the technology can help our breweries. We use 3D printing for safety optimizations. Secondly, we also use it to find applications for line optimizations. Finally, we also use it to make very fit-for-purpose tooling to enable, for example, better or safer or quicker maintenance. So we have multiple purposes where we use it for, and I think there will be even more purposes in the future.
We are starting to replace steel on 3D printing part. With the plastic element, the mechanical properties are very similar to the steel. Sometimes it's better. It's very easy to do different improvements. We can reduce the loss of the material. For example, this water around the conveyor sometimes jam in the sensor to detect the quantity of the water. This is a problem because normally it's a jam of different water. Now we create a modification in this sensor in order to it's impossible to produce the jam in this element.
At the moment, we really see that the technology can help us to localize part of our production. For example, when you look at Africa, we see that delivery times or lead times to get parts imported in some countries is really challenging. We are now able to produce them locally in our breweries or very close to our breweries instead of shipping them around the globe. So that's really where we see an advantage. What we've seen so far in the pilots that I've run is that we've significantly seen a decrease of cost. A cost reduction in the functional applications that we found from 70 to 90%. On delivery time, we've seen the same decrease, so also delivery time reduction of 70 to 90%.
Traditionally, in 2-3 days, it's possible to have this part here, and with the 3D printing, it's possible to design, it's possible to print in 8-10 hours, it's possible to run the line again.
In the coming year, we will start up multiple pilots to apply the functional applications we found in Sevilla, but also to find new applications and make sure that those will be scaled across the other breweries that are using the technology in order to leverage the advantages and scale the benefits.
Right, so I am very thirsty right now. It's almost to the end of the day in Japan. But it's a really good way for us to look into the ways that 3D printing can not only help, but a lot of these people haven't been traditionally trained on CAD operations. So having a very easy to use system like Fusion really helps them to start to take their designs. It really helps them to start creating basic functional parts that they can then instantly take into Additive. They can see how long it's going to take for them to print these parts, and they can start to actually implement it. So as you saw, a reduction in times from between 70 and 90% in downtime, as well as reduction in individual part costs because they don't need to go through external suppliers. I'm going to be wrapping it up in just a second and passing it on to the next speaker. One quick action that I would absolutely love for each of you to be taking part in is that the 3D Printing Industry Awards are coming up. We have the link here. I think that Varun is going to be putting it into the chat sometime soon. You can also scan this QR code. We're up for 3 different categories. Myself individually as Community Advocate of the Year for 3D printing. And we also have Fusion360 as the Software Tool of the Year, as well as Autodesk for Company of the Year. So if you could find a moment in your day, that would be amazing for you to help us support, to support us in not only our ambitions to ensure that we're getting recognized for some of the hard work that we're doing, but with these sort of things, it really helps us to also continue to focus on making sure that Additive is a high focus for our next level strategy. So if you can take a moment, there's a number of different categories. You don't need to answer all of them. If you don't know, or if you're unsure of what's going on in some of the other categories, you can just leave them. But if you can make sure to respond to these categories, that would be fantastic. I'll pass it back to the team. Thanks.
Thanks, Peter. Thanks for the great presentation. Guys, and we would need your support. Just check the link in the chat. That we will really appreciate if you can support us. All right, moving forward, So although I'm very sure we are going to be a little bit over time for today's presentation, so we have Prasad with us, and he will walk us through the advanced manufacturing capabilities with Fusion and some more information about the best practices. Okay, Prasad, over to you.
Let me share my screen, please. I'm Prasad Kulkarni. I'm leading the post-processor team for APAC. So today I'm going to run this advanced manufacturing and why Autodesk, right? So good morning, everyone. It's great to be here. Many thanks for spending your time with us today. I hope it's going to be good use of your time. This is a great opportunity for us to learn about your business, your challenges, and the needs for both now and for the future. It will also help you better understand how Autodesk see the market and give you insights into what we are doing to help our customers enable their competitive differentiation. I just want to cover three main topics. The one is the manufacturing industry trends we are seeing at a macro level. And the second topic, I would like to cover the opportunities for your business by evolving through disruption, and how Autodesk can help you realize these opportunities to achieve better business outcomes. Let's think for a moment of all the current initiatives and pressures we are facing in our day-to-day business and personal lives. So we are seeing challenges of increasing world population and the impact with the aging workforce. So this is the main challenge. So especially in India, we are not facing this aging issue because we have a large younger population in India, but rest of the world has started facing this aging population. So there is a increase in the world population. There is a more demand, but they are facing a lack of manpower. So because of the aging workforce, but there is an opportunity with the new digital and native workforce and automation through which we can overcome this problem. I have one of the case study where I will just discuss how the automation has helped to overcome this challenge. Right. So there is a challenge of climate change. So many of the great world leaders are talking about the climate change and how we can drive to eliminate impact on this environmental change. So this is the global problem. So everyone is talking on this climate change. But so how there is an opportunity with the new means of manufacturing and materials. So by adopting some new manufacturing technologies and materials, we can make a positive impact in this area. And the next thing is challenges from the increased global competition. So this is a main challenge. So everywhere the competition is increasing, there's a manpower problem, the costs are increasing, the product prices are decreasing, right? So, but there's an opportunity with the new technology, digitalization, and infinite cheap computing power. So using these technology, how we can bring the material product cost down and can be more competitive in this global market. So these threats and opportunities are impacting both you and for your customers. The question is, how are we going to respond? So this is a question in front of everyone. So how we are going to face these challenges? Supply chain flexibility and resiliency. So this has hit very badly. The supply chain management is a crucial part. More flexible, shorter and faster chain supplies, right? So and the next shoring. So this is one of the important things where all the companies started thinking on after this, especially after this pandemic situation. So localizing the supply chain and accelerating the innovation. So everyone is started thinking in this area because of this, because of the coronavirus, and it has hit the supply chain management very hard. So because of this, many of the industries started facing the heat. Like in today's newspaper, we see that many of the car production companies have stopped their production because the chip, they are running out of some of the electronic chip and sensor. So because they are dependent on some of the countries, and with the current crisis, so the supply chain management got disturbed. So the companies have started reimagining how they can accelerate the innovation and how they can localize this localize this supply chain management. And there's a digitization, so IoT of supply chain collaboration and inventory management. So these are the things where Autodesk can help you guys. I mean, we have the tools, we have the collaboration tool, we have the cloud product. So how we have helped our customers and how the companies have been successful by becoming more agile, by managing the effective remote working. So we are here to understand your journey and business goals that matters to you. So we recognize that you may be facing some challenges such as innovation, collaboration, digitalization, connectivity, and skill gaps. So these are all the challenges when I speak to any of my customers. So we are automating the manufacturing processes and knowledge through we have built the Forge platform where we can automate the manufacturing processes. You can collaborate with the cross-functional team and connect your data to reduce non-value added processes and aid supply chain agility. There are new manufacturing technologies as you have seen in Peter's presentation. So this 3D printing, adaptive machining. So there are many new technologies, manufacturing processes which have come up, and there are new materials in the market. So through which you can implement the advanced manufacturing solutions into your system. By implementing this, our customers have been able to overcome their challenges to achieve their business outcomes. So they have created the better products through improved product performance, aesthetics, quality, and reliability with the reduced environmental impact. This is just an example from oil and gas customer focused on providing downhole solution globally. So just they wanted to improve their operational efficiency and machine utilization at Dubai site of us. So we have reduced 80% of programming offline with the 5-axis machine, and 20% improved machine efficiency. So we have software which they were using previously, so which has saved them $70,000 maintenance cost reduction in that particular year. So these are all the Autodesk advanced manufacturing centers which are used to do some innovation, try some new things for the future of making things. So the future of making takes place in these centers. So from architecture, engineering, construction to manufacturing and generative design, these spaces exist to foster open innovation and advance in the industries that help to imagine, design, and make this world around us. So our network brings together industry, academic, and entrepreneurial communities to create a shared vision of the future of making. Quickly, so this is going to be my end of the slide. Thank you for your time today. So as a next step, it would be great to explore how do we see your future of making. So this can be through organizing a discovery workshop, so scheduling a follow-up visit to Autodesk Technology Center. Because of the pandemic, this can be only a virtual visit now. And also committing to a collaborative engagement if any of the guys wanted to have a deeper insights into the manufacturing technicalities. So you guys can reach out to us. We can schedule a dedicated demo for the manufacturing side.
Thank you so much. Thank you so much for sharing the amazing presentation, the intricacies. We discussed a few times, we are doing Autodesk University, which is the design and make conference that empowers you and the innovators everywhere to achieve the new possible. So I would request you, join your peers and fellow Autodesk community to learn from people and experts and professionals. And it's going to be all digital, it's free, and it's going to be an amazing experience. So we have like 3 different zones: Americas, EMEA, and APAC. So just find out the slot which is best suited for your timeline and just sign up for the classes, and you'll have ample amount of opportunities to learn by 350 plus sessions. You can just participate in industry talks. It will allow you to unlock great case studies, and the best thing that I feel is connect with people. Now, there will be ample amount of networking opportunities. Just meet with people, make relationships, create a portfolio. I'll again post the link, the sign up link. And in case you haven't, just check out what is there at the AU. Introduction. I might have to skip the Q&A because of the overtime. And we also have Anand Pujari with us. He's leading the education initiatives for Autodesk Education. He want to share a few things about what we are doing or Autodesk Education is doing specifically for the education community. Over to you, Anand.
Thank you so much, Varun. I know you don't have a time. I'll hardly take 2 minutes. I'll quickly share my screen and just to run through what we have on the agenda. Just a minute. Right, so here is the education part. As you mentioned, we would love everyone to register for it. There's a good package for the education community that some of the works being done by the student community are being presented. And there's a one good for the faculty communities that there are good speakers. We have a panel discussion. We have speakers from AICT chairman, that's Anil Sahasrabuddhe. We have industry speakers. We have design department speakers. All these are great speakers. You can see them on the screen. So I would encourage, this is going to be live, telecasted on 8th of October from 10:30 a.m. All the education sessions. So I would encourage them to be part of this. You will understand where we are heading, what kind of discussion, a good topic to be discussed and learned about it. And the second part I would like to highlight is about the classes that we have conducted from the student community themselves. There's a mentor and mentee program being how a faculty and a student journey talks about how they can collaborate and use our technology. The second approach is about learning the generative design applying to the landing gear class has been organized by the student community. And there is another approach of how differently you can go for your engineering drawing by Sharad Marathi. These are fantastic classes. We have recorded them. It will be telecasted on 8th. And not only that, at the bottom, what you see are 3 different projects are being clubbed. It's a 30 minutes video, which you will learn about how students have adopted generative design, manufacturing, and all these guys are winners of their competitions as well. So you will learn about these things. Additionally, whatever UG and Peter and Prasad talked about, all these different classes are being conducted in different topics under the Fusion sessions. You will see here a list of topics, okay, which will help you to learn more things. I'm just running it because of time short, but please make a note of this or register and go to the education community page. You will understand what are the different topics that you could really look at to attend during the year. Thank you so much, Varun. I just cut short my time here.
Awesome. So we are about to end this meetup, virtual meetup, and we still got like so many people who are still with us right now. So given the opportunity, any last minute thoughts, UG, Peter, Prasad, you want to share?
I don't mean to be last, but as you can see, there's so many great people, joining today and using Fusion 360 global, worldwide, and then we want to just make sure to share that we'll continue making investment, to the Fusion 360 development. And please stay with us and wait for the greater news in the next 2-3 years. And then we're gonna make so much. We have so much of plans. I can't tell you right now, but then we have so much fun plans coming. So stay tuned and join these meetings, meetups, events with us, and wait for more information to come. Very exciting news is waiting. All right, thanks for attending.
Thank you, Yuji.
I'd like to take a quick moment of yours. From Autodesk Community India also, we are hosting 4 meetups at the AU. So one of the highlights is the Fusion 360 meetup there. We'll be having Abhit Kumar from Social Hardware. Many of the panels will be there. So see you all there.
Absolutely.
Yeah, and just from me, I've added my LinkedIn to the chat. So if you had any 3D printing questions or anything that we didn't have time to get to today, feel free to send us a message, and I'd be more than happy to help you out. Looking forward to catching up with you guys soon.
Awesome. Thank you, Peter.
If any of the guys are looking for any specific manufacturing solution in detailed technical demonstration, please reach out to Varun so he can schedule for a demonstration with the technical guys. Thank you.
Very well said, Prasad. Thank you so much. All right, we are about to end, and I want to thank all our existing community partners who supported this meetup and leading the user engagement within their groups also. Thank you, everyone. Here we end this meetup, and thank you for staying with us. Thank you, Yuji, Peter, Prasad, Anand, and Bharat. I wish you all a great weekend. See you soon. Bye-bye.
Thank you, Varun. Thanks.
Bye, everyone. Have a good day.
Okay, bye, everyone. Take care. Bye.